take it apart so you don't have to. A multitude of cars. In each one, a motor burns fuel and produces toxic gases, nitrogen oxides, carbon monoxide, and unburnt fuel residue. Luckily, each car also has a catalytic converter located under the hood, attached to the motor right before the exhaust system. Gases produced by the motor go straight into the catalytic converter and come out the other side less than 1/10 of a second later. The converter gets less than 1/10 of a second to recombine toxic gas molecules and produce harmless substances like water vapor and oxygen. How? To understand it, we've got to destroy it. The stainless steel housing contains 2 ceramic blocks. Each block is filled with thousands of microducts. Their sides are coated with precious metals. Precious? Platinum and rhodium in the first block. Platinum and palladium in the second block. Metals that can cost more than $100,000 a pound. But they're worth every penny. Together, they have the extraordinary property of causing toxic gases to react and then recombine, producing gases that are harmless to your health. All that without altering themselves or rusting. Precious. The trick is to maximize the contact zone between gas and metals. That's why there are so many microducts, almost 400 per square inch. Their combined surface area matches that of a football field. A laboratory as big as a football field, but folded onto itself in order to remain small. The transformation of gas from toxic to non-toxic happens most efficiently when the catalytic converter is hot. Very hot. 1,300 degrees Fahrenheit. It's the toxic gases themselves that heat up the catalytic converter. They exit the motor at temperatures as high as 900 degrees Fahrenheit. The chemical reactions inside the catalytic converter also generate heat, transforming the converter into a super efficient furnace designed to break down and reform gas molecules. Let's take a closer look at these mysterious transformations. The nitrogen oxide and carbon monoxide molecules, along with the molecules of unburnt fuel residue, enter the catalytic converter. They're swallowed up by the thousands of microducts. As they reach the platinum and rhodium in the first block, nitrogen oxide molecules are the first to react. These metals break down the molecules by withholding one of their atoms. The freed atoms stick to each other and recombine. The result? Nitrogen oxide molecules become oxygen and nitrogen, which already make up 99% of the air that we breathe. The gas molecules now head into the second block, where the microducts are coated in platinum and palladium. These precious metals withhold oxygen. The intense heat here forces the carbon monoxide molecules to combine with the oxygen. The result? Carbon dioxide, the same gas that creates bubbles in soft drinks. Now for the molecules of unburnt fuel residue. At these extreme temperatures, their encounter with the oxygen forces them to recombine. The result? More carbon dioxide and water. All that in less than 1/10 of a second. In theory, the catalytic converter can eliminate 99% of a motor's toxic gases. In reality, it's inefficient as long as it's not hot. A car has to travel about 6 miles before the catalytic converter reaches its ideal operating temperature. That's 6 miles spewing untreated gases. In spite of the catalytic converter's best efforts, the car remains a source of pollution. But thanks to this miniature laboratory, it emits 5 times less pollution. That's still pretty impressive.